Okay, everyone. I think we're about good to get started. You have all eaten and are suitably sleepy to listen to a presentation about securing your Neo4j cluster with LDAP and Kerberos. My name is Johan Teleman, and I'm a software developer at Neo4j, working with Cypher and security. So let's start with talking about Kerberos. What is this Kerberos thing? We could be thinking of two different things here. Either we are talking about the Authentication Protocol Kerberos, which you use to authenticate users. You want to find out that the user is who they claim to be. That's the act of authentication. Or we could be talking about the mythological dog Kerberos, which is a three-headed beast that they use to protect the underworld of Hades from the living. I would not suggest that you use the mythological dog Kerberos to secure your Neo4j cluster. That could have unintended consequences. So we will be talking about the Authentication Protocol. So what is this Kerberos thing? Well, what most people associate that protocol with is tickets. And this is because when you typically authenticate yourself on some web service, you have a forum online, or you have your social network, or you have your computer. You tend to type in your username and your password. And that's also called credentials. But in the Kerberos world, these are always converted into a encrypted binary blob thing that's called a ticket. It doesn't actually look like that, but I had to type in something. And what you use these tickets for in Kerberos, the typical authentication situation is that your service, your Neo4j cluster or your application server is authenticating a user, so it's sure that it can serve the requests to that user. But in Kerberos, you can also do the other way around, or you can do both of them actually, which is called mutual authentication. And then you would also have your client authenticate your server, which is very good, of course, if you are connecting to some IP address. You want to be certain that the computer behind that IP address is actually the computer that you wanted to connect to. So this allows the protocol to protect against all kinds of attack, man-in-the-middle attacks, replay attacks, eavesdropping attacks, and other attacks. And this is achieved via symmetric key cryptography. And that essentially means that you will have a shared secret between the different entities in your network. So they will all have some keys that they know of beforehand that they can use to encrypt information and send between each other in a safe way. And Kerberos also relies on a trusted third party to do this. So apart from your user computer and your Neo4j cluster, there is going to be an authentication server, which is a third party that mediates the trust between the different entities. So Kerberos is not new. This is not the big buzzword you're going to hear about. It's very trusted. It's tested. It was invented in the end of the 1980s. And it started with version 4, because the first 3 versions were internal, but then version 4 was published from work at the MIT. Then some years later came version 5, which essentially refined some bits on exactly how to encrypt things and so on. And interestingly, from its publication until roughly the year 2000, Kerberos was considered auxiliary military equipment by the United States. So if you included Kerberos in your software, you could not export it. And this was because of the DES encryption algorithm that was part of the protocol. Funnily, since then, the security community in general considered DES to be quite bad. So no, don't use that. It's not the thing anymore. And about the same time that around the year 2000, Kerberos was taken up as the default authentication mechanism in this operating system, which you might have heard of. That's called Windows. So if you are on a Windows network with a domain server and you authenticate yourself, what you're actually doing is you're using Kerberos. So you're putting in your username and password, and it's going to be converted into a ticket, and under the hood, the ticket is passed over to the domain server, which is the authentication server, and it does all this for you without you actually knowing. And then by sometime 2005 or so, AES encryption was added to the Kerberos standard, and also some specifications on checksums and things like that. And since then, nothing really changed. So what are the good things? Why do we bother? Perhaps the single most important part of Kerberos is that you can achieve something that's called single sign-on. And this means that when you as a user arrive in the office in the morning and you sit down by your workstation, you're going to type in your username and your password. And then the workstation is going to perform a single sign-on authentication towards the authentication server, and you will get back a ticket which proves your authenticity. And then, when you want to connect to different servers or services, you will just hand over this ticket, and you won't have to type in your username and password anymore during that day, for example. This has the benefit that we do not have to communicate between the Neo4j cluster and the authentication server at all. We can just get the ticket and work with that. Another good thing about Kerberos is that it is very trusted and tested, as I just said. It's widely considered a secure protocol and powerful. And it is so also because we are never passing any credentials on the wire. So we do not transmit username passwords over the network. And that's very good because if we do that, then we are introducing attack surface towards our system. And then the single sign-on will allow you to not create any new credentials for Neo4j, and I will in a second talk a little bit more about that. So the downside, what you have to do with your Kerberos setup is that the actual setting up of the whole system is going to be slightly more involved and complicated, and that is because of this shared secret that I talked about before. So you actually need to distribute keys in a safe way and configure everything correctly from the start. And then something on passwords. I saw this ginormous paper about authentication protocols, where they clearly state that over 40 years of research have demonstrated that passwords are plagued by security problems and openly hated by users. And I think there is actually a lot of thought behind this, because one of the historically most successful methods of getting access to a system where you're not supposed to have access is actually to use social engineering and skills where you're interacting with the people who have access, and you manage to glance their password over their shoulder, or you can take a quick photograph of their post-its with their passwords or things like this. And having a mechanism like single sign-on will greatly reduce the risk of one of your 1,000 employees accidentally putting their password on a post-it and dropping it on a train or things like this. So that happens. So what the rest of this talk is going to be about is how you can use Kerberos in Neo4j, and that is possible with a new add-on that we have developed, which sits on top of Neo4j Enterprise, and that allows you essentially to authenticate your users via Kerberos. And we will now take a look at some example setups that you could use in your application, in your system, to achieve this. And then after that, we will peek at some of the details on how you actually, in practice, would go about to achieve this. So let's have some examples. Before actually going into Kerberos, I will take some time to look at what you would do when you are wanting to secure your Neo4j cluster with the vanilla Neo4j 3.1. And then you have to use the LDAP authentication mechanism. So in this slide, we have three different entities. We have the user on the left. We have the Neo4j cluster sitting on the right. And on the top, we have the authentication server. So in your Windows network, that would be the domain server. And what happens is that every time you make a new bolt connection, you're going to pass a username and a password. And then this is going to be sent to the cluster, and the cluster will, sometimes it will previously have handled this information, so it's cached and it can already know if this is a valid set of credentials. And other times it's going to have to escalate and ask the authentication server if this information is fine. So you can see that what happens is that you continuously send your credentials over the wire. It's not like it's completely naked because you can encrypt the connection and so on, but you are still sending them over the wire, which is bad. And you are also introducing extra communication between your Neo4j cluster and your authentication server, which of course can introduce higher latencies depending on your network speeds and depending on the geographical locations of your different computers. And it can also put more strain on your sort of authentication system. And the final thing to note about this is that every time you make a new connection from the user, you will have to actually retype your username and password, or you will have to store those things locally in memory on the user computer, which is also not the most ideal situation from a security perspective. So we will move on to see how we can change this, how this works using the Kerberos add-on. So we are still having the exact same entities as we had just a second ago. We have the user, we have the Neo4j cluster, and we have the authentication server. But what happens now instead is that your user will arrive in the morning, go to their workstation, and they will type in their username and password. I would do it over here, for example. And then their computer does the single sign-on and gets the authentication ticket from the authentication server. And then this ticket is going to be passed every time they make the bolt connection. When that arrives in the Neo4j cluster, the cluster will realize that, oh, I have a ticket, a Kerberos ticket. So how should I handle this? I'm going to pass it to the Kerberos add-on. And that Kerberos add-on is going to decrypt the ticket, check the validity of the user, and confirm the authenticity. So what this gives you is, as I stated before, you are no longer passing the credentials anywhere. They are kept locally in the user, and actually they're not even kept locally in the user because the user only sits on top of an encrypted ticket. And we also achieve the other thing, which is that we do no longer need to ask the authentication server anything from the cluster. So they can be completely isolated and do not know about each other in terms of authentication. And you can, of course, see the little three-headed dog that's supposed to represent the Kerberos add-on. So I haven't yet talked about the secret gray arrow in this slide, which says authorization. That is because, or the reason that this arrow exists is that the Kerberos protocol, as originally defined, does not support authorization, so it only supports authentication. And that is the act of confirming that the user is who they claim to be, whereas authorization is the act of checking if the user can do what they try to do. So in order to check the authorization of some action that the user is doing, we still need to revert to the LDAP realm setup. And that will, in the Windows case, actually mean that we're going to contact the Active Directory to check the rights or the roles of that user. And then finally, we're going to do one more example setup. And in this case, we're going to look at a slightly more evolved and complicated setup, which will be much more alike what you could see in a large-scale application where you use the Neo4j cluster to back your application. So you see now we have a whopping 4 entities on this slide. I know it's a bit much, 4 nodes, take it easy. But they're essentially still the same. We have a user on the left, we have an authentication server on the top, we have the cluster far to the right, and then there's just one layer in between, which is called the application server. Now I've drawn one of each, but you know the cluster is multiple nodes. The application server tends to be a bunch of servers, and the users are usually, you know, I don't know how many users you have, but say thousands, millions, whatever. So what happens is still the same. I am the user, and I will walk over to my workstation in the morning, and I will type in my username and my password over here. And then the single sign-on happens to the authentication server, and we get the ticket. But this time, we do not get the ticket for the Neo4j, because the application on the client doesn't really know about the Neo4j cluster. It's only knowledgeable about the application server. So we're going to get an application ticket, which allows us to connect to the application server. And then you know, however you implement your application server, it's going to check the validity of the ticket and all of that. But at some point, the request, you know, your application is going to try to do something, and to do that, it will need to make queries to your Neo4j cluster. And when it connects there, it is going to use a Neo4j ticket. And to get that, the application server has performed its own single sign-on towards the authentication server. And it's going to get a Neo4j ticket back, which allows it to connect. So on every Bolt connection, that ticket is passed to the Neo4j cluster. It's delegated to the Kerberos Add-On, which decrypts and checks the authenticity of the application server. So when the cluster sees that this is an application server that I know about and that should have access to do things, it's going to process the queries and so on. But isn't that a bit weird? You don't really want or you don't only want to know what application server that is making queries on your cluster. You really want to know what ultimate user that is making the queries. So in order to achieve this, you can use a feature which is in the product since 3.1, but not that well known perhaps, which is the transaction metadata. So you can add the ultimate user as metadata to a transaction, and then this will be shown in all listing queries, in the query logs, and so on. So you can use that to collect statistics or diagnose a live database as to what users are actually taking your resources and so on. So this setup would have the benefits that your client is completely blank as to if there is a Neo4j cluster and where that is and how that looks and all of these things. The application server is the only thing that knows about Neo4j. And then we annotate the queries. And what is also interesting about this is that you can actually fine-tune your system. So you will be able to find out at least how many Bolt connections will give me optimal throughput given the number of application servers and the size of the Neo4j cluster at the moment, and so on and so on. So you can fixate this number to whatever is the best. And then you will have your ultimate users share the Bolt connections. And they can do this because you can annotate for every transaction exactly what ultimate user is doing that, and they can go over the same connection. That's not a problem. So I think that's it for the example setups. I'm very happy to take questions about this later. Now we will finally look at some details on, no, actually we're just going to all together implement your application now. So if you want to use Kerberos, then you need this Kerberos Authentication Add-on. This add-on uses the public auth plugin API that was introduced in Neo4j 3.1. So you could use that API to create your own super awesome authentication plugin mechanisms. We used it to support Kerberos. And the fact that this is an add-on, it's not at all part of the product, so you can actually plug it into your Neo4j Enterprise 3.1 and later, and you can also plug it into 3.2 and later releases. And something which is very interesting to keep in mind and a bit tricky is that in Kerberos, everything is a user. So all your users are users, but also all your application servers will have their own users, and all your, even your authentication server has its own user, and your Neo4j cluster members have their own users, and so on. So that's something to keep in mind. And even though this is a separate add-on that you put on top of your server, the drivers are also amended to support this in a convenient way, as we will just see. So all of our official drivers are capable of thinking Kerberos. And we're just going to make an example. So this is going to be your application. Thank me for doing that later. What we're doing is something that looks just like the regular Bolt code that you would use on any Bolt driver. In this case, it's a .NET implementation. And there it makes a lot of sense because of the Windows systems using Kerberos by default. So what we do is just what we always do. The only difference is that we start by getting the ticket for the Neo4j cluster. And we pass that into the driver's API, which is to get an authentication or auth token using the auth tokens.kerberos. That's the first blue line. And then we get the token. And after that, it's all regular. We pass the token into the driver to make a driver with a Neo4j URL and so on. And the driver is used to get the session. And the session is used to run your extremely useful Cypher queries. And then we just handle the results and serve our users and so on. So this is the first of 2 slides on how your application is going to look. The second one comes here. And this is the slightly more tricky part, which describes how you can get a Kerberos ticket. So how this is implemented will depend quite a lot on exactly what your programming language is and what situation you're in. In this case, since we're on a .NET platform, all we're going to do is just to delegate all the complicated stuff to Windows libraries or Microsoft libraries, and then we're going to massage the results a bit. So that looks something like this. We get in the service name on the top, and then we need to find out what Windows domain we're on, so we get that. And then we use that to create a domain context. We just feed it in. And then an interesting part is this part where it says find user principal, find by identity, and we actually try to make a service principal name. So this is really a case where you can see that then we're trying to get a service principal name which describes the Neo4j cluster, but it says user principal, find by identity, and that's because it's the user for the cluster. So we feed in the service name, and then we get the service principal name. And after that, it's all pretty straightforward. We put that into the, to make a token provider. And then we take the token provider and we get a token. And what's nice to note there is that we actually define a period of time for which this token is valid. So you can see in this case, it's valid for 1 minute. And this is something you cannot really do in a username password-based system, where if someone gets access to a username password, then that is valid for, as long amount of time as it takes before you force your users to change their passwords. But in the Kerberos world, you can actually just specify that a certain ticket should be valid for some number of minutes. To get the single sign-on, for example, you tend to have a ticket that's valid for 8 hours. That's a typical workday. It all depends. But that's a very powerful and security functionality of this protocol. And then in the end, it's just some massaging again. We get the token, and then we convert this to a base 64 string. So that's the representation that the drivers expect of this binary encrypted blob. And this is roughly what you do. So there was supposed to be a URL on this slide. If you can see it, I think you're a bit crazy because it's not there. But if you want to get started, talk to us, and we will direct you to where you can go. So there is actually a landing page on the Kerberos Add-On. You can fill in a form So this is a add-on that we essentially charge for. It sits on top of Enterprise, but you can evaluate it and get hold of the code and the docs and everything like that. So you just need to find that spot. So I want to conclude this now. So we have made a new way that you can extend the capabilities of a Neo4j cluster using a Kerberos add-on, such that you can access Kerberos authentication typically via your Windows domain server that you are having anyway. This gives you the nice functionality of single sign-on, which lets you have fewer passwords and greater security, and it also gives you higher security by encrypting communications, not passing credentials, having time spans on your tokens, and so on. And this is available to extend Enterprise 3.1 and later, and also 3.2 and later. So I think we will do questions. I will stand outside to take questions. That's going to be fine. Thank you.